Electrical wire costs can vary significantly depending on several factors. Understanding these factors is essential for budgeting and planning electrical projects. Firstly, the gauge of the wire is a primary determinant of cost. In this case, we're comparing 14-2 and 12-2 wire. The number refers to the American wire gauge, or AUG. A lower number indicates a thicker wire. 12-2 wire is thicker than 14-2 wire. Secondly, the -2 portion indicates the number of current carrying conductors within the cable. In both 14-2 and 12-2, the 2 indicates 2 current carrying conductors, plus a grounding conductor, for a total of 3 wires inside the cable's jacket. The thicker the wire, the more copper it contains, directly impacting the price. Copper is the primary conductive material in most electrical wires, and its price fluctuates on the commodities market. Thirdly, the jacket material also affects the price, with different plastics and compounds offering varying levels of insulation and protection. Fourthly, the location of purchase influences the price, as different retailers have different overhead costs and pricing strategies. Prices may vary between local hardware stores, big box retailers, and online suppliers. Fifthly, market conditions play a role. Supply chain disruptions, increased demand due to construction booms, and other economic factors can all cause price fluctuations. Sixthly, the quantity purchased can impact the price per foot. Buying in bulk often results in a low price per foot compared to buying shorter lengths. Seventhly, wire type matters. NMB, or non-metallic sheath cable, is commonly used for residential wiring. Other wire types, like THHN or MC cable, have different construction and applications, influencing their costs. Now let's delve into the specific cost comparison between 14-2 and 12-2 wire. The information suggests 14-2 wire costs $60 and 12-2 wire costs $102. Without knowing the length of wire these prices refer to, it's difficult to directly compare the price per foot. However, we can assume these prices are for a standard length, such as a 250-foot roll, to illustrate the cost difference. Suppose both prices are for a 250-foot roll. Then the 14-2 wire costs $60 for 250 feet, and the 12-2 wire costs $102 for 250 feet. To calculate the price per foot, divide the total cost by the length. For the 14-2 wire, $60 divided by 250 feet equals 24 cents per foot. For the 12-2 wire, $102 divided by 250 feet equals 408 cents per foot. This means 12-2 wire costs approximately 168 cents more per foot than 14-2 wire in the scenario. This difference is attributable to the greater amount of copper in the thicker 12-2 wire. Now let's discuss the applications of 14-2 and 12-2 wire. 14-2 wire is typically used for 15 amp circuits. This includes lighting circuits and general-purpose outlets that do not supply high-demand appliances. According to the National Electrical Code, or NEC, 14-gauge wire is rated for a maximum of 15 amps. 12-2 wire is typically used for 20 amp circuits. This includes kitchen outlets, bathroom outlets, and other circuits that may power appliances with higher power demands. The NEC rates 12-gauge wire for a maximum of 20 amps. Using the correct wire gauge is crucial for safety. Overloading a circuit with undersized wire can cause the wire to overheat, potentially leading to a fire. It is essential to consult the NEC and local electrical codes to determine the appropriate wire gauge for specific applications. It is also important to consider voltage drop. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source. This can cause lights to dim and appliances to malfunction. Thicker wires, like 12-2, have lower resistance and therefore less voltage drop than thinner wires, like 14-2, over the same distance. When running long circuits, it may be necessary to use a larger gauge wire to minimize voltage drop. For example, if you're running a 15 amp circuit over a long distance, you might choose to use 12-2 wire instead of 14-2 to reduce voltage drop. When making electrical connections, Use appropriately rated connectors and ensure they are properly tightened. Loose connections can cause arcing and overheating, creating a fire hazard. Always turn off the power to the circuit before working on electrical wiring. Use a voltage tester to verify the circuit is de-energized. If you are not comfortable working with electricity, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Regarding the specific prices in Clifton, New Jersey, it's essential to confirm these prices with local suppliers. Prices can change frequently, and it's best to get a current quote before starting your project. Also, inquire about any applicable discounts or promotions that may be available. When purchasing electrical wire, check for certifications from organizations like Underwriters Laboratories or UL. UL certification indicates the wire has been tested and meets safety standards. Proper installation is just as important as using the correct wire gauge. Follow the NEC guidelines for wire routing, securing, and protection. Avoid running wires through areas where they could be damaged, such as doorways or under carpets. Use cable staples or ties to secure the wire to framing members. Protect wires from physical damage by using conduit or other protective measures where necessary. Remember, electrical work requires careful planning, attention to detail, and adherence to safety regulations. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns. Understanding the cost differences between wire gauges, like 14-2 and 12-2, is a crucial part of the planning process. The initial investment in the correct wire gauge will ensure safety and proper operation of electrical systems. Additionally, consider the long-term costs associated with using undersized wire. Potential issues like overheating, voltage drop, and the risk of fire can lead to costly repairs and replacements. In summary, when planning your electrical project, consider the following. Firstly, determine the appropriate wire gauge for the circuit based on the amperage and application. Secondly, compare prices from different suppliers to find the best deal. Thirdly, factor in the cost of connectors, boxes, and other necessary materials. Fourthly, ensure all materials are UL certified and meet local electrical codes. Fifthly, follow proper installation techniques to ensure safety and reliability. Sixthly, if you are unsure about any aspect of the electrical work, hire a qualified electrician. By carefully considering these factors, you can ensure your electrical project is safe, efficient, and cost-effective. Consider that a 20-amp circuit requires the use of 12-2 wire. If you are wiring new circuits in a residence, the NEC requires arc fault circuit interrupter, or FSI, protection for most 120-volt circuits. The FSI breaker protects against fires caused by arcing faults. Ground fault circuit interrupter, or GFCI, protection is also required for certain locations such as bathrooms, kitchens, and outdoor outlets. The GFCI breaker protects against electric shock. When working with electrical wire, it's also important to be aware of the different color codes. Black and red wires are typically used for hot conductors, white wires are used for neutral conductors, and green or bare copper wires are used for grounding conductors. Always double-check the wiring connections to ensure they are correct. Incorrect wiring can create a shock hazard or damage electrical equipment. Also consider the type of insulation the wire has, as that will affect the temperature rating of the wire. In addition, when estimating wire costs, don't forget to account for waste. It's always a good idea to purchase a little extra wire to allow for mistakes or changes in the layout. It's also important to store electrical wire properly to prevent damage. Keep it in a dry place away from direct sunlight and extreme temperatures. When pulling wire through conduit, use a wire lubricant to reduce friction. This will make it easier to pull the wire and prevent damage to the insulation. Before connecting any wires, make sure the ends are clean and free of insulation. Use a wire stripper to remove the insulation without nicking the wire. Use properly sized wire connectors for all connections. Do not use wire nuts for connections involving stranded wire and solid wire. Use a connector that is specifically designed for this purpose. When working with metal boxes, be sure to ground the box properly. This will help to prevent electric shock in case of a fault. Consider using a surge protector to protect electronic devices from power surges. Power surges can damage sensitive electronic equipment, so it's a good idea to take precautions. When working with electrical tools, always wear safety glasses and gloves. This will help to protect you from injury. Inspect electrical cords and tools regularly for damage. Replace any damaged cords or tools immediately. If you are working outdoors, be sure to use a GFCI protected outlet. This will help to prevent electric shock in wet conditions. Be aware of the location of underground utilities before digging. Contact your local utility company to have them mark the location of underground lines. Also consider the ampacity of the circuit when selecting wire. Ampacity is the maximum amount of current a wire can safely carry. The NEC provides tables that list the ampacity of different wire sizes and types. When calculating the load on a circuit, be sure to include all appliances and devices that will be connected to the circuit. Do not overload a circuit. Overloading a circuit can cause the breaker to trip or the wire to overheat, potentially leading to a fire. It is important to remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician. Trying to do electrical work yourself without the proper knowledge and experience can be hazardous. It is important to be aware of the risks involved and to take all necessary precautions to avoid injury or property damage. Always turn off the power to the circuit before working on any electrical wiring. Use a voltage tester to verify that the circuit is energized. Never work on electrical wiring while standing in water or on a wet surface. Wear rubber-soled shoes to help protect yourself from electric shock. Keep children and pets away from the work area. Do not allow children to play with electrical cords or outlets. Be careful when working near overhead power lines. Maintain a safe distance from power lines to avoid electrocution. If you are working on a ladder, be sure to use a ladder that is rated for electrical work. A fiberglass ladder is a good choice because it is non-conductive. Avoid using metal ladders near electrical wiring. Metal ladders can conduct electricity and pose a shock hazard. When working in a confined space, be sure to provide adequate ventilation. This will help to prevent the build-up of flammable or toxic gases. Do not smoke or use open flames near electrical wiring. Flammable materials can ignite and cause a fire. If you smell gas, evacuate the area immediately and call the gas company. Gas leaks can be dangerous and can cause explosions. When working with electrical equipment, follow the manufacturer's instructions carefully. Improper use of electrical equipment can lead to injury or property damage. Store electrical equipment in a safe place where it will not be damaged. Keep electrical equipment away from water and moisture. Inspect electrical equipment regularly for damage. Replace any damaged equipment immediately. If you are unsure about any aspect of electrical work, consult with a qualified electrician. An electrician can provide you with guidance and advice to help you complete your project safely and successfully. Remember, safety is always the top priority when working with electricity. Take all necessary precautions to avoid injury or property damage. By following these safety guidelines, you can help to ensure that your electrical project is completed safely and successfully. Consider factors like the length of the wire run, the load on the circuit, and the type of wire being used to determine the appropriate wire gauge. For example, a long wire run will require a larger gauge wire to minimize voltage drop. The NEC provides tables that list the allowable ampacities of different wire sizes and types. Refer to these tables to ensure that you are using the correct wire gauge for your application. Also, consider the type of insulation on the wire. Different types of insulation have different temperature ratings. Choose a wire with an insulation rating that is appropriate for the environment in which it will be used. For example, if the wire will be exposed to high temperatures, you will need to use a wire with a high temperature insulation rating. Be sure to use the correct type of connectors for the wire you are using. Different types of connectors are designed for different wire sizes and types. Using the wrong type of connector can result in a loose connection, which can cause a fire. When making connections, be sure to strip the insulation from the wire properly. Use a wire stripper to remove the insulation without nicking the wire. A nicked wire can break easily and cause a short circuit. Be sure to tighten all connections properly. Loose connections can cause arcing and overheating, which can lead to a fire. When running wire through walls or ceilings, be sure to protect the wire from damage. Use cable staples or clamps to secure the wire to the framing members. Avoid running wire over sharp edges or through areas where it could be damaged. Be sure to ground all electrical boxes and equipment properly. Grounding helps to protect against electric shock in case of a fault. Use a ground fault circuit interrupter, or GFCI, to protect against electric shock in wet locations, such as bathrooms and kitchens. A GFCI will trip the circuit breaker if it detects a ground fault, which can help to prevent electric shock. Be sure to follow all applicable electrical codes when installing wiring. Electrical codes are designed to protect people and property from electrical hazards. If you are unsure about any aspect of electrical wiring, consult with a qualified electrician.